Okay, guys, we're going to look at 5.4, and while we're going to be using congruent triangles in this lesson a little bit, we won't be proving triangles congruent as much as we have in the last couple of lessons. So today we're going to look at the base angle theorem, and in order for us to look at that, we need to understand what base angles are. So when you have an isosceles triangle or an equilateral triangle, but I'm going to just look at the isosceles triangle. Remember that that means that there are two congruent sides. And so the congruent sides are called legs, and then the other side is called a base. And the base angles are the ones obviously attached to the base. So we've got a base angle there and a base angle there. And then the angle that is located between the two legs is always called the vertex angle. So in the base angles theorem, it says the base angles in an isosceles triangle are congruent. So if I put that in if-then form, if it is an isosceles triangle, then the base angles are congruent. And then obviously the converse of that is when we switch the if and the then part. So if the base angles of a triangle are congruent, then it is an isosceles triangle. So if I gave you any triangle and told you that two angles were congruent, you can call those the base angles, which then mean that the sides opposite those angles are congruent, and therefore making it an isosceles triangle. Here is a little proof of the theorem to show you why it works. So this blue line is called an auxiliary line, and auxiliary means helping. So we're going to add that line. So the plan for this proof is that you're given an isosceles triangle. So we are given, that AB is congruent to AC. And then we're going to draw in AD. So really we're going to bisect angle CAB. And we're going to use, we're going to say that we're going to use the definition of an angle bisector to do that, because we are actually drawing one so that we bisect the angles. So I'm making that angle 1 and angle 2. So once I do that, I can now say that angle 1 is congruent to angle 2. And there's your definition of an angle bisector again. So you know that we have these sides congruent. We now have the angles congruent. And now, just like you did on your other homework, you can say that AD is congruent to AD. And it can be reflexive property, or it could be shared side. And that's enough to be able to say that our two triangles are congruent. And I'm going to say triangle ADB is congruent to triangle ADC, and that's SAS, like you did last night or the other night for your homework. And then remember that once we know that triangles are congruent, we can say that other parts of them have to be congruent. And that is, and I'm going to use my little shortcut that I use, CPCTC, which when I say it out loud sounds funny, but it's Kapuktika. And all that means is corresponding parts of congruent triangles are congruent. And so that's a little shortcut that you can use. C, P, C. Oops, I forgot the word triangles. T, C. So that is why the base angle theorem works. And applying the base angles theorem is very straightforward. So for this one in triangle DEF, it tells me that these two sides are congruent, and it wants us to name angles that are congruent. So they're going to be the angles that are opposite those two sides. So that'll be very straightforwardly. Angle F is congruent to angle E. And down here, I want you guys to fill in this. I'll pause and then I'll come back to tell you what the answers are. There you go. I put numbers in those angles to make it a little bit easier. But if you didn't put numbers in the angles, just look carefully at the letters to know that you chose the right ones. So now we're going to look at a corollary to the base angles theorem. And as you recall, a corollary is something that is related to a previous theorem. So in this case, if I have an isosceles triangle that has two base angles, then that means that an equilateral triangle, basically any two angles could be considered a pair of base angles, depending on where you're looking. So obviously for this one, I have three congruent sides, making it equilateral, and three congruent angles, because from any particular point of view, for example, I could make these my congruent sides, and these would be my congruent angles. And I could do that for any two sides, and that shows that all of the angles and sides are congruent. So very straightforward. If the triangle is equilateral, then it must be equiangular. And the converse, if it is equiangular, then it is equilateral. And because we know that all three angles in a triangle add up to 180, we know that that means that each of these is 60 degrees. So I want you to try this one. And I'm going to pause, let you guys try it, and when you come back, the answers will be there. So there you go, guys. Y ends up being 7, and X ends up being 15 degrees. Notice up here that I made that a linear pair, and that's what helped me set up my equation using the fact that this is a triangle and adds up to 180. So here is another one that I want you guys to try. And work on that, and then I'll come back with the answers. So using the base angles theorem, I was able to make both of these equal to x plus 1. And then you can see that this triangle is equilateral, so all sides are congruent. And that is what set me up that these would be the same. But that's how I know that y equals 4. And from there, it helps me figure out that x equals 3. So here, guys, I'm going to show you how to do parts A and parts B. So part A, it says, explain how to prove that triangle QPS is congruent to triangle PQR. When you have diagrams like this with lots of different triangles happening, I pay close attention to that statement, and then I draw those triangles separately. So I'm going to draw QPS and then PQR. So now I've sort of separated those two. You can see that they overlap a little bit in the middle. And now I'm going to add my given information up here. So it tells me that PS is congruent to QR. That's awesome. And it tells me that angle QPS is congruent to angle PQR. So I have an angle and I have a side. And I want to point out that when you have triangles that are being overlapped, you actually end up having a shared side because they're right on top of each other. So we know that PQ is congruent to itself because PQ is congruent to PQ. And that is enough to be able to say that those triangles are congruent because of SAS. Now, once I know that those triangles are congruent, I know that the other parts of it the other corresponding parts are also congruent. So now I know that this angle and this angle are congruent because of Kapuktika. Corresponding parts of congruent triangles are congruent. And if I color those in over here, I think you can see it shows up pretty well in my diagram here, that if those angles are congruent, then that must make, see if I can get a color that will show up really well for you. That makes this triangle isosceles because of the base angles theorem. Hopefully that makes sense to you. Now I want you to, so even though there's two of them here, I'm only going to have you do example 4. So try that one and then come back and check for your answer. There you go, guys. You end up with x equals 60 degrees and y equals 120 degrees. And then on your last page, coming up, you have a puzzle. So here, give these a try. And then if you want to do these and you want to check your answers, you can just put them in your notes and I'll take a look at them. Or you can send it to me separately and I'll take a look at it.